For 25 years, Soar Technology Inc. has been a world leader in artificial intelligence, machine learning, and advanced computing. Known for our open-source Soar cognitive architecture, SoarTech was founded by Dr. John Laird of the University of Michigan, created to continue support for DARPA's Synthetic Theater of War. We are a small business with headquarters in Ann Arbor, Michigan, and an office in Orlando, Florida. We primarily do defense research solving the military's toughest problems through AI that is trusted, trustable, and trustworthy. For this effort, the challenge is to address the persistent occurrence of spatial disorientation across aviation. Spatial disorientation happens to all types of aircraft, fast jet, fixed wing, and rotary, and to all levels of pilots, and is trained as part of initial training and recurrent training at the Naval Survival Training Institute's Aviation Survival Training Centers. Recent analyses suggest that presenting numerous mishap narratives in a more engaging way might improve training efficacy and retention for spatial disorientation. The Navy's requirements for immersive spatial disorientation training included the content being authorable by instructors, license-free, and capable of presenting a variety of spatial disorientation scenarios, including both the most common ones and ones that haven't happened yet. Current spatial disorientation training includes a wide variety of exposure types, from lecture to experiential. There are lecture-based classes that show spatial disorientation and discuss what happened, how it happened, as well as the physiology of spatial disorientation. There are barony chairs that are used to demonstrate to a student how their proprioceptive system can trick them. This is achieved by spinning the student around with their eyes closed, stopping the spin, then having the student point to the direction of the turn. Typically, the student will point to the opposite direction. There is also the Multi-Station Disorientation Device, or MSDD, that is a multi-arm centrifuge spinning students at the end of each arm on a localized axis, while the entire device also spins around a central axis. Each pod has a window that can open or close and the ability to do small proxy tasks for flight. Students are spun, and then the windows are opened, or the students are asked to perform tasks at crucial parts of the experience, and the students can then see how their eyes and proprioceptive systems can play tricks on their perception. Level D simulators with 6 degrees of freedom and full motion platforms provide high-resolution flight training and can also be used for some spatial disorientation training, such as unusual attitude recovery. It does not, however, provide the full vestibular experience that leads to spatial disorientation. Finally, storytelling is seen as a way to share what happened with fellow aviators and provide more examples of what can occur during spatial disorientation, giving pilots a large sample of the ways in which spatial disorientation can occur and putting it in context of the first-person experience. Wingman allows instructors or safety centers to create or recreate mishap scenarios, giving pilots a first-person perspective of a mishap. With high-resolution imagery, actual terrain models, and the ability to add instrumentation and voice, Wingman allows the student to see from the pilot's perspective what happened, hear what was said and when by ATC or the crew, and create a mental model of the incident in first person as it happened. Flight data can also be directly ingested into Wingman to create these narratives. Instructional points can additionally be added to provide supplementary information, show diagrams, and provide lecture voiceovers. Wingman also supports the creation and export of 360-degree videos, such as are found in head-mounted displays. This allows instructors and safety centers to quickly and easily create safety memos, incident instruction, and training modules that are custom to their own units and instruction styles. There is low overhead with no licensing or special equipment required, and the scenarios are widely distributable. They can be exported as simple XML or exported as movies, and they give instructors the flexibility to create their own content as needed when needed. Wingman was awarded a Phase 1 with several other performers, and was down-selected with 2 other performers to participate in the Phase 1 option and the Phase 2. At the end of the Phase 2 base period, Wingman was again selected to continue development with 2 subsequent Phase 2 options. Wingman is currently on a Phase 2 expansion, creating more scenarios and integrating with physiological monitoring capabilities, exploring additional spatial disorientation training paradigms. Wingman has several key features that make it a solution for mishap creation. Developed with a game-based authoring tool, there is both real-world terrain and sandbox terrain available, with aviation lighting. An aircraft carrier with aviation lighting is also included, all license-free. Features that are key to spatial disorientation, such as the sun, moon, and celestial body positions, can all be customized, as can overall lux, and clouds and weather are able to be set precisely in a narrative to achieve the required visual occlusion and masking. Wingman supports brownout and whiteout conditions as well, and it includes a highly realistic night vision goggle capability modeled by an MH-60 aviator. And it supports single or formation flight with multiple tracks with nearly a dozen airframes. As discussed, Wingman also exports videos to a 360-degree video format, playable from YouTube to mobile phones. The anticipated fleet transition communities includes the Naval Surviving Training Institute Aviation Training Safety Centers. Wingman is a standalone software and isn't currently investigating programs of record. For deployment, Wingman needs some hardening and testing, as well as potentially some optimization for any target deployment hardware. We are currently seeking assistance for transition advocacy. In the commercial sector, spatial disorientation also continues to be an unrelenting issue, particularly for general aviation and Part 135 on-demand flying. The Federal Aviation Administration, however, does not currently require spatial disorientation training, although the National Transportation Safety Board concluded that more training on spatial disorientation mitigation is needed following the crash that killed basketball star Kobe Bryant and 8 others, including the pilot. There is interest from commercial airlines in the utility of the storytelling and recreation method for spatial disorientation training that Wingman provides, particularly since there are not other available interventions to completely train to spatial disorientation. They may lack the accurate proprioceptive or visual cues, or the element of surprise, or they train the sensations and perceptions specifically without tying them to a specific use case and mitigation. Wingman has been briefed at the World Aviation Training Symposium to a positive response from world-leading airline training departments. For follow-up questions, please contact SoarTech and Principal Investigator Amanda Bond at the email or phone number you see on the screen. Thank you for listening.